All right, hey everybody, Mr. Jones here, and we are going to continue on talking about solving quadratics. And if you guys remember from my last video that I talked about with using the quadratic formula, um, right? This last problem that I solved out, you guys saw that I plugged everything in. I found my A, B, and C values. I plugged it all in. I simplified, and then we got to this point, and we said that okay, because this was a -4 in this radical, there could be no real solutions to it, right? And I said I would explain later on why that was or what we could say instead. Okay, and this is later on. I'm going to explain it right now. Okay, so what we're going to introduce here is something that's called a complex number or an imaginary number. Okay, that's what this I stands for. This is the letter I. I just make it a little curvy because it kind of looks like a 1 sometimes, but yeah, this is going to be our letter I, and that just, yeah, letter I. Letter I kind of means an imaginary number, okay? And why do we do this? What's this for? Well, this is so that we could kind of simplify this, okay? We know that there's going to be not a real answer to it, but we could actually take this a step further if we were to kind of say something like, okay, if we were to deal with this negative radical and kind of write it as if it were able to be solved out, then we could move forward and kind of simplify it a little bit further. Okay, so this imaginary number is kind of a placeholder to allow us to move forward with problems that do have a negative radical. Okay, so just this imaginary number, this unit, right, this letter I, equals the square root of a -1. Okay, that's just what we say that it stands for. Okay, so for example, if I was to say like, okay, what's the square root of -25? Okay, like what's the square root of -25? You would say, okay, there's no real solution there, right? Because no two real numbers can, all right, no real number multiplied by itself can equal -25, right? But how I could represent that if I was to say, okay, what if this, what if I change this? Okay, so what you would do here is say, okay, I can kind of separate out, right? Because I could rewrite -25. I could rewrite this as -1 times the square root of 25. So kind of separating that negative from the number itself. Okay, so if I was to say, okay, -1 times -25, or the square root of -25, and I said, okay, right, this square root of -1 is where my I comes in. So because these two things are equal, I can change this -1 to be just the letter I times, and then what's the square root of 25? Well, 5, right? Positive 5. Okay, so I could say, and just kind of flipping this, I could say that, okay, the square root of -25, I could represent that with 5i. Okay, I could say that's 5i would be another way to simplify this. You might be thinking like, that's pointless, why do we do that? Like I said, it's just a way for us to kind of move forward with problems that usually we would just kind of be stuck when we have this negative radical. Okay, so we can get it to be a little bit simpler than just saying the negative radical. Okay. So that's what an imaginary number is. It's kind of a way to represent a negative radical. Okay, now back to this problem. I said no real solutions. Okay, but now that we kind of have an idea of what an imaginary number is, let's move forward with this problem knowing that. Okay, this is still true though. Okay, there are no real solutions. That is true. So if you were to say that about this problem, you would not be wrong. Okay, but now that you know what imaginary numbers are, you would be expected to say, okay, what would be the imaginary or complex solutions? Okay, a complex solution would be like a problem that would have both real numbers and complex numbers within them. Okay, and that's what this is going to be. Right, if I just, let me just rewrite that. Okay, so if I have this, right, 2 plus or minus the square root of -4 over 2, right, I can now just take that radical part, kind of like how I did with 25 or -25 here. I could change that. I could say, okay, 2 plus or minus, right, the square root of -4, right, the same process here, right, I could kind of separate it, separate the -1 from it, right, and that's -1 times +4 is -4, right, so the square root of -1 is I, and the square root of +4 is 2. So I could say the square root of -4 would be 2i, right? And so I could replace the square root of -4 with that. Okay, so I could instead write 2 plus or minus 2i over 2. Okay, and now look, right now I can divide, right? Because this is saying 2 plus or minus 2i, both divided by 2. right? So if I did divide both of these numbers by 2, I could simplify it, right? So this would be saying like 2 divided by 2 is 1. And then 2I divided by 2. Yes, these 2's can divide. Even though this has that imaginary I with it, that 2 can be divided by this, okay? So I would just say 1 plus or minus I would be my answer, okay? So 1 plus I and 1 minus I would be 2 imaginary solutions to this quadratic equation, okay? Now that's a little taste of it. We're going to go over a little bit more here. I'm going to do one more problem, kind of fully worked out, simplifying these, but that's the idea. Okay, I just wanted to quickly introduce that to you. And we are going to get more into these imaginary and complex numbers in other videos, but that's all for this one. So let me just go through one more problem dealing with this, and then we'll be all set. Okay, so you see you got number 2 up here, and number 2 similarly is a quadratic equation. And let me just tell you too, we use the quadratic formula when these would not be able to be factored. So if you wanted to try to factor these with tic-tac-toe, you could try all the different combinations, all the possibilities in there. It would take you a while, but you would eventually find that you could not factor, unfortunately. Okay, so that means my only real possibility for this is to solve it with the quadratic equation. Okay, so that means that, right, I have to first identify my A, B, and C numbers, right? So A is 2, B is 6, C is 9. They're all positive, okay? And so then substituting it back into the formula, okay, I can do that real quick. Okay, so there it is, all plugged into the formula. And again, it's just a matter of simplifying this, right? So I have that negative 6 outside, plus or minus 6 squared is 36, right? And then minus 4 times 2 times 9. So minus 4 would be, so 4 times 2 times 9, sorry, it would be 72. Okay, so that'd be minus 72 over 2 times 2 is 4. Okay, and then, yeah, working this out further, right, I would have negative 6 plus or minus 36 minus 72 would be the square root of negative 36, right? So again, at this point, right, you could see that, again, it's just what's in the radical determines this. You would say that there's no real solutions. Okay, that negative in there is going to determine that. So yeah, we would say for this problem, no real solutions, but I would still be responsible for saying finding the imaginary solutions as well. Okay, so again, from here, it would just be taking this, I'll rewrite it, taking this and simplifying this square root of negative 36. Again, same process as I've done a few times now. So it would be, right, the square root of negative 36. I would kind of separate out the negative from that. So it would be the square root of negative 1 times the square root of positive 36, okay? And so then the square root of positive 36 is 6. And so basically it would be, this would turn into 6i, okay? I'm not showing my work for that one just because I wanted to go quick here. But yeah, so it'd be negative 6 plus or minus 6i over 4, okay? And then, even though 4 doesn't divide evenly into these, I can still reduce this, right? Because they're all even numbers, and that's the way you can reduce it. So what you would say is, right, if I divided all these numbers by 2, cut them all in half, I would say negative 3 plus or minus 3i over 2 would be how I could reduce this. And that's as simple as I could make it right there. Okay. So there would be 2 imaginary solutions to this, negative 3 plus 3i over 2 and negative 3 minus 3i over 2. Okay, but no real solutions. All right, so I hope that makes sense. That's just a little taste of imaginary and complex numbers and answers. Again, like I said, we'll get more into it in other videos, but that's all for now. Thanks for following.